Hi folks, we're going to take a look at 15b from page 400. So they want us to find the components of a vector OP that has these characteristics. So essentially with these direction angles. So beta, so angle to the y-axis is 30, gamma, angle to the z-axis is 60, and alpha, angle to the x-axis is 90. Okay, now I notice in the question it says find a vector that has these properties. So that seems to indicate that there's likely more than one answer. Okay, so since they're giving us the direction angles, let's work with those definitions of our direction angles. So here, what this tells us is that cosine of 30 degrees, because that's beta, is going to be equal to the y component of this vector over its magnitude. Okay, cosine of 60, okay, because that's gamma, is going to be equal to z over the magnitude of the vector. And here alpha, so that's to the x-axis, so cos of 90 degrees is going to be equal to the x component over the magnitude of the vector. Okay, so we'll work with the definition. So first and foremost here I see that cos of 90 is going to be equal to 0. And so the only way for this fraction to be equal to 0 is for the numerator to be equal to 0. So we know x has to be equal to 0, so that's done. For these here though, is I can calculate cos 30, I can calculate cos 60, okay, but I've got two unknowns on the other side of the equation. Well here, since we're looking for any vector that has these characteristics, why don't I choose to find the vector that has magnitude of 1, okay? So in this case here, we have that y is just equal to cos 30, okay, and cos 30, well, is just going to be root 3 over 2. And here, that means that the z component is just going to be equal to cos 60. Okay, and cos 60, that's just going to be equal to 1 over 2. Okay, and so our vector OP is just going to be equal to x equals 0, y equals root 3 over 2, and z is equal to 1/2. And this is one vector that has these characteristics. Now, just in case you want to check that, I didn't just pull this out of a hat, let's check that this vector actually has a magnitude of 1. Okay, so let's find the magnitude of OP. So here we have 0 squared plus root 3 over 2 squared plus 1/2 squared, which is just equal to the square root of 3 over 4 plus 1 over 4, which is 1. So there you go. It's a unit vector, and since this is a unit vector, it means that our choices here for y and z are going to work. Okay, so just to recap, because I'm given information about these direction vectors without even thinking about where this question is going, just write down your definitions for these direction angles. Okay, once you have that, we were able to determine that the x value had to be equal to 0, and from there it was just realizing that there was many vectors that have these direction angles. Okay, we just happened to pick the one with magnitude of 1. I could have picked one of these that has magnitude of 2, and I would have just gotten an equally good answer. Okay, that's it for this one.